Okay, folks, my lesson today is revolves around factors of improvement. All right, and there's some reading your textbook about this, and there's also a little bit of notes in the Moodle shell. So I'll start out by just reviewing this here. So a factor of improvement is where we calculate it. We're always dealing with rates, right? We're not dealing with just raw quantities. We look at the new rate, and we take that new rate and divide it by the old rate, right? So I'm going to do some comparisons here. One of the very common technologies that we have out there is known as USB. We plug in all sorts of USB devices. We recognize that they come from different ages and different eras of computing. And so we actually right now on the marketplace, I believe we have 3. USB 3.0 might just have come out here recently. But we definitely have a ton of devices that are USB 2.0, and then you might have really old, like USB drive or something, you plug it in, it's really slow. Well, it might be a USB 1.1. And these are right next to us here. These are the transfer rates. All right, so USB 1.1 transfers data, and again, we're using our metric prefixes here, but it transfers data at 12 megabits per second. Okay, so that's a rate. It's bits per second. All right, not just bits, but bits per second. USB 2.0, 480 megabits per second, and then USB 3.0 is 1.5 gigabits per second. All right, so let's do some comparisons here. Let's compare USB 2.0 with USB 1.1. All right, so this is a really easy problem because we can just put the new rate and divide it by the old rate. Oops, 480, let me get the units correct here. Eraser's not quite getting it on here. There we go. Let's try that again. So it's 480. Okay, now we got mega, just abbreviate that with the M, and then the unit here is BPS, or bits per second. Again, mega bits per second. Both these are rates, they'll cancel each other out. We'll come up with what? Well, what's 480 divided by 12? Well, that comes out to be 40. Is that correct? 4 times 8 is 48. All right. And so we lost our units here. So we have a factor of improvement here of 40, or a way we might represent that is we might say that USB 2.0, you'll find this on a lot of boxes that tout these devices, is 40 times faster. Okay, let's do one other one here, and we'll just compare USB 3.0 with USB 1.1. All right, so USB 3.0, only difference we have here is that we got to convert our metric units again, and so 1.5 gigabits per second. Well, giga, stick back to our unit on work with the metric system here. Giga is going to be larger than mega, so let's first start by converting this. So this is going to be, we move the decimal point 3 places. So it's going to be my zeros here. Move it from here, 1, 2, 3. So this is to keep our units the same. 1 gigabit per second, or 1.5 gigabits per second, is actually 1,500 megabits per second. Now our units are the same. It's important. Our last problem, we had our units the same, so they cancel out. So we'll take 1,500 megabits per second. We'll figure out the factor improvement on that. Compare that. Let's compare it with USB 2.0. So that's 480 megabits per second. Okay, and this is a good time. Use your calculator. Nothing wrong with that. I'll call mine up over here. All right, and let's do a little division here, 1,500, and we'll divide that by 480. All right, so we end up with a little different factor of improvement. So 3 point, sorry, what was that? What do we say? 3.125, okay? So really we can look at, the difference, and I'll round here, okay, use approximately. We'll see that USB 3.0 is approximately 3 times faster than USB 2.0, all right? So we can compare these new technologies. The last example that I have for you here, all right, I'm going to scroll down the page. We'll do another factor improvement that maybe hits a little closer to home here. All right, let me move down this a little bit. All right, so here's my last problem here. All right, and where this might come from. I'm maybe in a shower there, and I got a shampoo bottle, and on that shampoo bottle, it's a 16-ounce shampoo bottle, and it touts itself as having 20% more than the regular size. All right, so the question is, what's the regular size of this particular shampoo bottle? All right, or actually, excuse me, I'm going to change this so our numbers work out evenly. Look at my notes here, and this kind of comes out to a little bit of an odd number. Let's do an 18-ounce, okay? All right, so I don't really have an 18-ounce bottle of shampoo, but you'll get the idea, right? So I have an 18-ounce bottle of shampoo here, and so I want to figure out what's the size of the regular bottle, not the new and improved. All right, so let's use our rates again. All right, so I want to come up with oops, let me grab the right tool here. So I want to come up with factors of improvement again. All right, and I really want to show that it's truly 20%. Okay, so our factor of improvement, we take our new rate again divided by our old rate. The only problem is here, I don't really have, excuse me here, why can't I get my right tool? There we go. I don't really have a rate here. I just have ounces, okay? So we need to change that to rate, and this will seem a little trivial, but we got to use rates here. So my new rate, I have 18 ounces. I'm going to use this notation here. 18 ounces, here's the rate, per bottle. Sounds odd, it works. Okay, we do miles per hour. We do megabits per second. Now I'm going to do 18 ounces per bottle. That's our rate here of our new bottle. Our old rate, we don't know what it is. So I'm just going to use a variable here, and I'll say whatever the old bottle was. All right, we're going to do a little algebra here, nothing really super complex. And if it's 20% more, then really my factor of improvement, and I'm not hiding anything here, I don't think, should be 1.2. Wasn't that our definition here? Okay, so 1.2 is 20% more. Okay, so the bottle is actually 120% its size. So remember, just some conversions here. 120% is equal to 1.2. All right, so that bigger bottle has 100% and then 20% more. That's how I get that from. Okay, so don't be confused of it. All right, so let's move some things around here algebra-wise. Well, I need to multiply both sides by my variable. My variable here I have is old bottle. Not a very nice variable. But if I multiply old bottle on both sides, these guys cancel out over here. Okay? So now I'm going to just use commutative property here, nothing, again, very sophisticated. So 1.2 times old bottle being a variable, it's now going to be equal to 18 ounces per bottle. Okay? Divide old bottle by 1.2. do the one side, you gotta do the other side. All right. Now again, use your calculator. Okay with that. We'll line up here again. So I take 18 and divide it by 1.2. That comes out to 15. So my old bottle is now equal to what? 15 ounces. And again, it's a rate per bottle. All right, so there's kind of a consumer example of a factor improvement. All right, we have a new bottle, it's 18 ounces, the old bottle was 15 ounces, and yeah, what gives here? There is actually 20% more in that new bottle.
Want to save that